Okay, the inverse normal distribution is just doing what it says on the tin. It's taking you back the other way, so you're performing the opposite to what we were doing last lesson. You don't need to know any more than that about it. You'd be pleased to know, but you do need to be able to use your calculator. So your calculator gives you a value A, where the probability of x being less than A is equal to P. So that's a lowercase p for probability. So in this example, it's the one at your book as well, so you're welcome to have a look at it in there too. But so we've got mean 20, standard deviation of 3, and we want to find A such that the probability of x being less than A is 0.75. So I'm hoping to get a bit of light on this if I can. Right, so it's menu 7, and we want inverse normal, which is option 3. And the area to the left of A is 0.75. Standard deviation is 3, mean is 20, and you're told it's 22.02. It is useful just to be able to sketch these. So what's going on with this is we've got this normal distribution centred at 20, A is at 22.02, and the probability of being to the left of A is 0.75. So the area under the graph to the left of A is 0.75. For this one, the probability x is bigger than A is 0.4. So that probability there is 0.4. But your calculator only does less than, so you need to change that one into the probability of x being less than A, or you can write that as less than or equal to, it doesn't make any difference because it's continuous, is equal to 0.6. And then from there, I'm just using my calculator. So again, plugging in, I think actually, yeah, all I need to change is this bit here to 0.6 because it stores it. I had the light on that a minute ago, it seems to have disappeared. There we go. And then press equals, and I've got 20.76. And then this one here, probability 16 is less than x is less than A is 0.3. So if I do a quick sketch, so I've got 20 there. 16 is going to be, it's one and a bit standard deviations from the mean, so it's going to be a bit of a way down. And the probability of being between here and A is 0.3. So I would put A about here. But you know when you do your work whether it should be that side or that side of 20. So your calculator will only do to the left of probabilities. So what we're going to have to do is find this little bit of area here, and then we can do this bit plus 0.3, and that's the probability of being to the left of A. So I need to find, first of all, the probability of x being less than 16, and this is what you were doing last lesson. So menu 7, normal CD, lower bound, just I'd put in minus 1,000 or something, upper bound 16 is stored, that standard deviation, and I get 0.0912. Right, what I can do with that, you don't want to get any rounding errors, obviously, in your work, so you can store that to x, and it's stored to x, so you can do that at that point there. And so now I actually can work with the probability of x being less than A is 0.3912, and then I can go into my inverse normal to find A. So menu 7, inverse normal, And then the area is 0.3 plus x. And when you press equals, you can see that's 0.3912, just in case you were worried. And then that gives me A as being 19.17. So it's very much calculator exercise, but make sure you're okay with these stitches because it will serve you well later on. I'm going to try and squeeze another one into this video and not regret it. So, second one, we've got plates are being manufactured to have a diameter D. D is normally distributed, mean of 20, standard deviation 1.5, which seems quite high for a plate, but never mind. And we're told that 60% of the plates are less than X. So for this one here, we're just told that the probability of D being less than X equals 0.6. That's just like I was doing on the other exercise. It's just a little bit wordy, that's all. So I think I was on inverse normal, but so option 3, area is 0.6, standard deviation is 1.5, and the mean is 20. And that gives you 20.38. So 60% of the plates have a diameter of less than 20.38 centimetres. And don't ask. And the interquartile range. So to find the lower quartile, you do probability of D less than X is equal to 0.25. Or you could call that Q1, actually, couldn't you? So that'll give you your lower quartile. The upper quartile is the probability that D is less than the upper quartile, which is Q3, is 0.75. Sorry, that's like my worst writing ever. It's because I'm standing up. Right, try sitting down. Right, Q1, up, lower quartile. Q2 is equal to the median. And Q3 is the upper quartile, just as a quick bit of revision on quartiles. And then you can work those through in exactly the same way. So it's just inverse normal, 0.25 for the lower quartile. That gives you 18.988. And then doing the same for the upper quartile, so 0.75. Gives me an upper quartile of 21.01. And then the interquartile range is upper quartile minus the lower quartile, and that gives you 2.02 centimetres. And remember, for symmetrical distribution, the mean, median and mode all have the same value. So your interquartile range will sit either side of the median, which will be the centre of your distribution as well. I think that's it. I'll let you get on with a few.